So, so good morning all. So this is the video lecture on data structures. Currently we are discussing with module 4. So module 4 we have seen trees. So different types of trees we have seen. Next we have gone with properties of the trees. Next we gone with traversals, in order, pre-order, post-order. So now you come for the new concept, very important concept, threaded binary tree, expression tree, and application of trees. So these are the last three topics of your module 4. So first you see what is threaded binary tree. So threaded binary tree. So why you need a threaded binary tree? So that we shall see in today's class. That is why need threaded binary tree. So reason for we have binary tree. So why you need threaded binary tree? So for that, what is the disadvantage of binary tree and why you need threaded binary tree, that we will see in this particular paragraph. So in order traversal can be either be done using recursion or with the use of stack. So keep in your mind, in order traversal, so you have done traversals in order, pre-order, and post-order. So now you see, so what you have did, so you have inside a function pre-order, you have called again the pre-order function. That means, so pre-order of root then left, pre-order of root, pre-order of root then right. So that means you are calling the function again and again. So that is leading to the one of the problem. So idea of the threaded binary tree is to make in-order traversal faster and do it without stack and recursion. So why you need the threaded binary tree? To make the in-order traversal without using stack. Okay, so now you shall see what is a threaded binary tree. So binary tree is made threaded by making all right child pointers that would be null to the in-order successor of the node. So what is the definition of the threaded binary tree? A binary tree is made threaded by making all the right child pointers. So which are the right childs in this particular diagram? So 8 is the right child. So 5 is the right child. 11 is the right child and 13 is the right child. So right child pointers which do not have any children. So right child pointers who do not have any children are made to point to the in-order successor. Okay. Who is the in-order successor? So for 5 is the right child, in-order successor is 6. For the left child, in-order predecessor is 3. So that we have to see in the next coming. So there are two types of threaded binary tree. One is single threaded, the other one is double threaded. So come for single threaded. When a right null pointer, that means only one thread is there. So which is the one thread? So it is the right pointer is made to point to the in order successor. So right pointer is made to point to in order successor. Okay. So similarly, you come for the double threaded. If it is single threaded, you will have only right pointer. If it is double threaded, you will have both left and right null pointers. So when you call it as a null pointer, so we will call it as a null pointer when they do not contain any children. So both left and right pointers are considered as threads when they do not contain any children. So at that time we consider them as null. Here you see this is the left child pointer. It doesn't contain anything. So we consider this one as left child pointer, this one as right child pointer, and 7 is also considered left child pointer. 9 is left child and 13 is right child pointer. So when both left and right null pointers are made to point to, see that, so left will point to in order predecessor and right will point to in order successor. Keep the meaning respectively. Respectively means, so we are using two. So left will point to in order predecessor and right will point to in order successor. If there is single threaded, so right will point to in order successor. Okay, so predecessor threads are useful for reverse the in order traversal and post order traversal. Okay, so can you tell whether it is single threaded or double threaded? So seeing the diagram, now can you say whether it is single threaded and double threaded? So whether now you tell it is single threaded or double threaded. Is the dia single threaded or double threaded? Just tell me now. So it is single threaded. How come? If it is single threaded means, keep in your mind, only right child should point to the in order successor. So only the right child should point to the in order successor. When you come for the double threaded, both left and right child will point. Okay, so at that time you see here you see this one is left child is pointing to in order predecessor, and right child is pointing to in order successor. So at that time we call it as a double threaded. So in this particular diagram we see both left is pointing and also right is also pointing. So here left is pointing. So now we consider this one as double threaded because both left and right child are pointing. If only right child is pointing, then we consider it as single threaded. Okay. So what is the use of using threads? So threads are useful for fast accessing the ancestors of the node. So threads are needed for fast accessing the ancestors of the node. So now you come for the in detail of threaded binary tree. Okay. So in detail of threaded binary tree, now you see what are all the things we do here. So now keep in your mind, left child will point to in order predecessor. Predecessor means before. Successor means after. Okay. So before and after. Okay. Left will point to before and right will point to after. So threaded binary tree. So we can reuse that empty links by making some threads. So which is the empty link? So here you see which are the empty links you are having. So here you see this one which doesn't contain. So for which node you can use threads, I will tell you. So if that node doesn't contain left or right child, so that one can be used as a thread. Okay, so come for here 56, it is containing both left and right child. So come for 23, it is containing both left and right child. So come for 20, left part. So left also containing left, but you see the last node 12, it doesn't contain any children. So at that time, now we tell it points to, this is the left child. So left child will point to in order predecessor. Okay. So similarly, right child will point to in order successor. Okay. In order predecessor means before. In order successor means this one. So similarly, this one is left. It is pointing to in order predecessor. Predecessor means before. Okay. So 12 can make point to 23 or 12 can also make to 56. But right child, you see the right child, it should point to one level before that only. Okay, so that one we are making used as threads. So if one node has some vacant left or right child, that can be used as thread. Okay, if some node has vacant left or right child, so that can be used as thread here. There are two types of threaded binary tree. The single threaded tree, so single threaded tree or full threaded binary tree. So now you see here in single threaded mode, there are two variations. One is left threaded, the other one is right threaded. So there are two types of the single threaded or fully threaded. These are the two types, single threaded or fully threaded binary tree. Okay, so threaded binary tree will consist of how many types? Two types, that is single threaded or fully threaded. In single threaded, there are two variables. One is left threaded, the other one is right threaded. So see what happens here. In left threaded, if some node has no left child, then left pointer will point to in order predecessor. So similarly, in a right threaded mode, if some node has no right child, okay, so left threaded means no left child, right threaded means no right child. So left threaded mode, if there is no left child, then left pointer will point to in order predecessor. Similarly, in a right threaded mode, if some node has no right child, then the right pointer will point to in order successor. So left will always point to in order predecessor and right pointer will always point to in order successor. In both the cases, if no successor or predecessor is present, then it will point to the header node. So when it points to the header node, when it doesn't contain any successor or predecessor, then it points to header node. Here you see this one is not finding any predecessor or successor, so it is pointing to header. So here it is pointing to header. So here it is pointing to header. Okay, so this is single threaded. So single threaded, it is left threaded and right threaded. Okay, so now you come for the second one, that is fully threaded. So for fully threaded binary tree, each node has 5 fields. So which are the fields? So one is the tree node. The other two fields to store the Boolean value to denote whether the link of that is actual link or not. So this is the, each node has 5 fields, 3 fields, 3 fields like binary normal binary tree node. The other two fields to store the Boolean value to denote whether the link of that side is actual link or thread. So here you can see here. So in this, so this one is left threaded mode. This is single threaded mode. This one is fully threaded mode. So fully threaded, here you can see there. So this one is pointing to here. This one and this one is pointing to here. This one is pointing and this is fully threaded. But when you come here, this is left threaded or right threaded. Okay, so this is the left threaded or right threaded mode. This one is fully threaded mode. Okay, so now you come for the demo. So how the threaded binary tree will work. Okay, so first this is the tree structure. Start at the leftmost node and print it. So this is the tree structure I have given. One will point to in order. So in order means how? Left, next you will get root, next you will get right. In order means root will come in between left and right. Okay, so in order, predecessor means so root, so this one will point to left, and in order successor means after right you will get 6. So this is the connection that you will be representing like this. Okay, so first start from leftmost node, you will print 1. Now 1 is come here. Next from 1, what is the next node you have? 3. So next after 3, now you see which is the node you are containing. After 3 we have 5, that's we printed 1, 3, 5. So after that 5 is pointing to 6, that's why you get 1, 3, 5, 6. Next you come here. So come for the rightmost. So rightmost you will be left child you are having because this is the root. Again, you go with the in order. So in order means first you will get root, first you will get left, next you will get root, next you will get right. So that's why we have, for here, we got 7. Next you have gone with 8. Next you go with 9, 11 and 13. So that means all the in order means all the things are sorted. So here you can see after 7 and 8, you will get 9, 11 and 13. So that is the threaded binary tree, how you are going to travel. Okay, so suppose if you are going to travel from node 1 to node 13, so node 1 to node 13, we give it as 1, 3, 5, 6, 7, 8, 9, 11 and 13. So continue in the same way for remaining nodes. So which are the remaining nodes we have not put? 9, 11 and 13. After 8, here it is again 11. So come for the leftmost part, 9, 11 and 13 will be the output. Okay. So after that, now you come for the next one. So this is the, so how you represent the C representation of the threaded node. So how you represent, so following is the C representation of the single threaded node. So single threaded means, so you can either contain left threaded or you can get right threaded. So first you have taken in terms of struct node. So that node is pointing into data. Next struct node star left and star right and boolean. Okay. Since the right pointer is used for two purposes, the boolean value right thread is used to indicate whether the right pointer points to right child or in order successor. So similarly, we can have left thread for double threaded. So in order traversal that we can see like this. So leftmost. So this is the video question, C representation of the threaded node. So how you represent, you have to write this particular program code. So leftmost, that means this is for left threaded. So left threaded binary tree. So if it is null, if n then left not equal to null, keep on going for n is equal to n then left. So in order traversal we can tell you, so in order will always start with leftmost, next data. So if current not equal to null, print the data. So next you go with a rightmost. So this is the rightmost. Okay. So first you will get leftmost, next you will get data, next you go with the rightmost. So this is the code for C representation of the threaded node. Okay. So after that, now you see, you have to tell what is the advantages of threaded binary tree over binary tree and explain the construction of threaded binary tree. So what is the main, what is a binary tree? So you have to write binary tree is made threaded by making all right child pointers normally be null point to the in order successor. So what are the advantages? Makes it possible to perform in order without stack. So next, makes it possible to back up to higher levels. So from leaf you can travel to root node. So what are the construction of threaded binary tree? So threaded binary tree, first you go 10, next 20, 30, 40 and 50. 40 will point here, 50 will point to 10. Okay, so this is the threaded binary tree. So level order scheme visit the root first, then root next left child, next followed by the root's right child. So use of the, what are the methods? Use of parent node to each node, use of 2 bits for this one. So threaded binary tree. Okay, so now you have to tell, this is the video question, rules to construct the trees. So rules for constructing the trees, I have already told it here. So next 2 methods that you have to write. So for in order traversal of binary tree, so in order traversal I have written leftmost this part. So the same question you have to consider it here. So leftmost. So here you have to go with in order. First you take the leftmost, then you print the data. Next you go with the right thread. So this is the video questions what they have asked from this particular concept. Understood? So understood the concept of threaded binary tree. So use this link to answer your attendance. I hope everyone has understood up to what is threaded binary tree and how you construct the threaded binary tree with fully threaded and left and rightmost threaded. Okay, so this is up to today's class. So remaining another next concept we have expression trees. So expression trees that we will see in the next after the internals. Okay. So kindly, if you like the video, if you want to go for next coming videos, kindly subscribe, like the videos, give the comments and subscribe for the channel. Okay. So I will be ending this particular session. Thank you one and all.